Hello student. Yes, so in this video we are looking at making of the subject of the formula. This is a very simple math algorithm. And it is a very simple and interesting piece of mathematics. So if we are making the subject of the formula, simply entails get all the things, put them on one side, leave on one side what I've been told. For example, if I have a plus b plus c plus a is equal to b plus c plus d, such that they tell me to make c the subject of the formula. If I'm told to make c the subject of the formula, I will just take b and d the other side, such that if I change that kind of setup, I'll have c will equal to an a minus open brackets b plus d. As simple as that. So if I call this one 1, in my 2, if I have py squared is equal to qy squared plus maybe zy squared plus w, and they tell me to make y the subject of the formula. I told you, just if they tell me to make y the subject, I need a single y on one side. So this one has no y, I can bring it to this side, and then this one has a y, I take it to the other side. So you'll have negative w will equal to a qy squared plus zy squared minus py squared. Then we've dealt with factorization in our former videos, so if you are kind of not well conversant, visit those videos. So what we do, we factorize out y squared because it's common, so you'll have y squared into q plus z minus p will equal to negative w. But then I've been told to make y the subject, so I don't need these bodies here. I divide through by q plus z minus p, divide by q plus z minus p, so that this one's my y squared is equal to a negative w out of a q plus z minus p. So for our case, we're going to take the square root on both sides, but to avoid taking the square root of a negative thing at our level, let's take this negative downwards and make the thing positive, though you can still take it. So if I take this guy down, this and this become negative, p becomes positive, so my y squared can equal to w out of p minus q minus z, such that I can now take the square root to remove the square. I take the square root here, then I take the square root still here, so the square and the square root sign go because it is a half. By indices, y is equal to w out of p minus q minus z under a square root. So let's look at more interesting numbers. So we have another interesting number where we need to make q the subject. So we still follow simple mathematical algorithm. So if I say solution, as part of our solution, we have p plus 3q divided by q minus 3p is equal to x out of y. So what we do, we can cross multiply. If we cross multiply, we are going to have a y into p plus 3q then is equal to an x into q minus 3p. What do we see? The y multiplies each component, yp plus 3yq is equal to xq minus 3xp. But remember, we are making q the subject, so let's get all the things that have q, put them on one side. Those that don't, we put them on the other side. So the easiest, I bring this negative this side, this one the other side, so that I have yp plus 3xp will equal to a q, an xq minus 3yq, because I'm interested in making q the subject. We've enjoyed in our former videos a lot of factorization. Still, let's employ here factorization. Q is common, we pull it out, so that I have yp plus 3xp will equal to a q into x minus 3y. Sorry, x minus 3y. So the final step is I divide through everything by x minus 3y, x minus 3y, divide here by an x minus 3y once such that my q is finally equal to a yp plus 3xp divided by x minus 3y, as beautiful as such an algorithm. So we have here another interesting number whereby we have make a the subject in c is equal to a squared out of a minus b. So if we take this as part of our solution, we have that c is equal to a squared out of a minus b into a plus b. So what do we see here? One of the simplest is here an a squared, but then if I'm to recall, we are expanding this guy, bringing it up and making it disappear when we are dealing with factorization. So let's now take it back to a difference of two squares. So I have c is equal to a squared divided by a difference of two squares here. So I have a squared minus b squared, so that I can multiply. This is over 1, multiply or cross multiply or multiplied by a minus b squared. So I have c into a squared minus b squared is equal to a squared. So that I have ca squared minus cb squared is equal to a squared. I bring the a this side, take the cb squared the other side, so that ca squared minus a squared is equal to a cb squared, such that I can factorize out a squared into c minus 1, because if I remove here a remain with c, if I remove here a remain with a 1, not a 0. So this is going to be cb squared. I divide through by c minus 1, so that a squared is equal to cb squared out of c minus 1. I'm only remaining with removing the square, so I simply take a square root. So that my a squared is equal to I have this as cb squared out of c minus 1, as simple as that. Yes, so we have our last number to work out with. We have n is equal to x root of 2 out of m squared minus 1. Express m in terms of n and x, in other words make m the subject of the formula. So as part of our solution, we have, we repeat, n is equal to x, the square root of 2 out of 4m squared minus 1. So the first thing is we can square both sides, or we can first remove this guy, the x here, so that I divide here by x, such that n out of x is equal to x out of x, which is 1, square root of 2 out of 4m squared minus 1 x1 once, so that I can square both sides now. N out of x squared will equal to the square root of 2 out of 4m squared minus 1, such that I have this as n squared out of x squared. We are squaring, sorry, we are also squaring here, so that the square and the square root sign go will equal to a 2 out of 4m squared minus 1. Yeah, such that I have this body as n squared out of x squared is equal to a 2 out of 4m squared minus 1. So what I can do is let us learn a very interesting math phenomenon, that is the double reciprocation. Yes, you can work with it a little bit. Let us learn something very new, double reciprocation. So I'm going to take the reciprocal on both sides because I'm interested in leaving m on one side. So double reciprocate x squared out of n squared is equal to 4m squared minus 1 out of 2. Yeah, that is allowed. It is double reciprocation, and mathematically will not have changed anything. Multiply both sides by 2 and add 1 on both sides. So I'm going to have 2x squared out of n squared. If I multiply it by 2 by 2, then this negative 1 after multiplying by 2, I can add it on both sides. So plus 1 is equal to 4m squared. then I divide through by a 4, such that if I divide each term now here by 4, I can have an x squared out of 2n squared. I'm dividing by 4 by 4 by 4 each term, plus a quarter is equal to m squared. I'm trying to use a shortcut so that people don't get bored. I want to remove the square. I take the square root, such that if I take the square root, my m squared will equal to the square root of x squared out of 2n squared, and then plus a quarter. Yeah, you can further simplify what is in brackets by taking the square root as 4n squared, and then, but you can leave it like that. Oh, this is, I've taken a square root on both sides. It means this part here, that part there disappears. Yeah, it is as simple as that. I took the square root, so when I take the square root, this square here disappears. Yeah, I was trying to make it 10 minutes, but I've gone to 11. Yeah, so but hope you are trying to follow. And anywhere you don't understand, you can join my inbox. You can WhatsApp me on my numbers. I'll always be there to help you. Thank you.